Hey, we're ReCVE, and I'm Stephanie Smith.
I'm Trace Engel.
I'm Tyler Harkness. And I'm Vincent Vu.
Smith, and I'm going to give you a little introduction on ReCVE. So, obvious question, what is ReCVE? Well, ReCVE is a software vulnerability management solution. But before I get too much into that, I'm going to ask you a question. Is all the software in your computer up to date? Probably not. This means that you could have outdated software in your computer that has bugs in it, some of which might be known security vulnerabilities. ReCVE helps you find and manage these security risks. These vulnerabilities are documented as CVEs, which stands for Common Vulnerabilities and Exposures. This is just an industry standard for documenting software vulnerabilities. So we check all of your installed software to find these CVEs, and we give you the information and tools to manage the security risk of these vulnerabilities. The best part about ReCVE is it works on a network of computers, which allows you to centralize this process for all of your computers. So who's using ReCVE? ReCVE is designed to be used by administrators of a small to medium-sized network of computers. An example of a medium-sized network might be a small business with 10 to 50 computers, and a small-sized network might be a home administrator with 1 to 10 computers. These users want to minimize their security risk and understand the state of their computers. ReCVE allows you to do this far easier than it would be to do manually, and it centralizes the process for you, so you don't have to go computer to computer. So how we do this is through a set of our key features. So our main features fall into 3 categories. Security management, which is largely what we've been talking about up till now, which is just information on these CVEs and also help managing these CVEs. And then we have user-focused design, which is just to enhance the user experience. And finally, we have professional features, which are useful for users who are frequently using the software. For example, a business might want to use the data exporting feature to create reports for their business. I'm going to hand this off to Trace, who's going to give a demonstration of ReCVE.
So once the server is installed and running through Docker, you're going to want to navigate to the web interface. Now, if you're doing this on the machine the server is running on, the address will be localhost. But if you want to access this from anywhere else, you'll actually have to enter the machine's IP address. For example, this is this machine's local IP address, so this is where I would go. Now, once you get here, you'll be greeted by a blank dashboard because the database is currently empty. And if you've installed any daemons on any other computers on the network, you can find them listed here in the All Devices page. And we can see that they've already sent their software information. And we can go ahead and update all their vulnerabilities to actually get this dashboard working. Now, this will take a while, so don't worry if it doesn't complete right away. So once that's finished, the database is now updated with every vulnerability it found, and there's an entire list here. And we can go back to the dashboard, and so now these line graphs have been updated with a singular point, so there's no line yet. The pie chart and heat map have some data. There's a security score. That is the average of all the NIST vulnerability scores, where lower is better. And you can customize this dashboard to suit your taste. If you click this wrench icon, you can add a bunch of different data that you want. You can rearrange stuff. So if I want the pie chart first, I can do that. And this is saved and updated, and all the information is here. So if we go to this heat map, if we click on high, we can see this computer has 15 high vulnerabilities. So if we go to that device, we can see its software, and we can see all the vulnerabilities it found for the software. And if we sort by the highest score, so the most vulnerable, we can see this application, NVIDIA GeForce Experience, has a CVE, and you can click it to see the details of the CVE. So there are some other tools to help you manage your computers. There's this device usage graph, which shows the CPU and memory usage every 5 seconds. It is similar to Task Manager. You can sort by CPU and memory. This graph is the last 30 minutes, and it's live, and it updates every 5 seconds. We can also change it to look at the entire history. So we see here there's kind of a bump in CPU usage. If we zoom in a bit, we can see it's definitely higher than everything else. So we can kind of click one of these and see which process was actually using the most CPU and memory. And this can be helpful for looking at, what processes were using the most resources in a given time frame. And if you have a bunch of computers, but you want to manage them separately or kind of group them together, specifically for scanning because it takes a while, you notice how devices have a default group. We can go into the groups page and actually make them a separate group, and you can set a scan time and an interval. So if you want it every few hours or every few days, you can do so, and we can change which clients are actually in this group. So if we go here, now they will scan their applications at different times.
And here we can see a diagram of ReCVE's architecture. The daemons compile a list of software and running processes from their device and send this information to the server. The server then uses this information to query the National Vulnerability Database for any vulnerabilities. It then stores all software and any associated vulnerabilities in the local database, which is hosted on the same machine as the local server. It then visualizes any found vulnerabilities on the web interface. The ReCVE server was built on .NET Core's Model View Controller web application framework. The ReCVE server and database were containerized together using Docker. Remote desktop access was implemented using NoVNC and TightVNC VNC clients. The daemons were written from scratch. The Windows daemon was written using C#, and the Linux daemon was written in C++. The Linux daemon supports Red Hat Enterprise, Arch, and Ubuntu Linux distributions. The user study was conducted in collaboration with cybersecurity professionals, a computer engineering student, and a home administrator. These individuals all had varying levels of expertise in cybersecurity and represented our target audience. After deploying ReCVE to the local networks that each individual oversaw and letting them use it for a while, we gained some very valuable feedback and used this feedback to make sure our final product was well tailored for use by these individuals. And this included adding guidance for those users that perhaps had less expertise in cybersecurity. We also added ways to navigate between pages on the web interface easier. And we also relabeled and reorganized our data so that they were represented in a more intuitive way. So thank you very much for watching and taking an interest in our project.